Okay, guys, this is part 2. More evidence of global climate change. Carbon dioxide is a minor but very important component in the atmosphere. CO2 is good at holding heat. Humans have increased atmospheric CO2 concentrations by more than a third since the Industrial Revolution began in the late 1700s to the 1800s. So we're going to look at these two graphs, and I want you to highlight, or actually not highlight, I want you to answer in that box right there below the following questions. Not just the question that's in there, but these other things. I think I made the box big enough for you to answer 3 things. What is the title of the graph? So the Mauna Luau Observatory monthly average of carbon dioxide. So put that in that box. What are the labels for the X and Y axis? So for the X axis, we have years. And for the Y axis, we have carbon dioxide. And then the main thing I want you to think about is what pattern do you see in the CO2 levels measured in Hawaii's observatory from 1960 to 2015. So you can see the red line is the carbon dioxide, and then there's a blue line that's underneath that. That's harder to see, but it says trend. So it's showing you there is an upward trend. We will come back to the other one in a second. So CO2 levels increased from 315 ppms, which is parts per million, to 400 ppms over those years from 1960 to 2015. All right, and then on the circle or the pie chart, first question, what's the title? Put that in that box. So the total U.S. greenhouse gas emissions. Second question is, what is this graph showing you? What I want to know are which areas emit the most gas. So looking at this, transportation is 29%, electricity is 29%, industry is 22%, commercial and residential is 11%, agriculture is 9%. So list the 3 sectors or sections most responsible for greenhouse gas emissions. So 29, 29, and 22. Write those 3 down in your box. I have less room than you, so I abbreviated. All right. Fossil fuel versus renewable resources. Fossil fuels were formed over millions of years from fossils, or the remains of dead animals and plants buried under dirt and rock. Heat from inside the earth and pressure from the dirt and rock changed the fossils into oil, natural gas, and coal. It took millions of years to make fossil fuels, and we call them non-renewable resources because we're not going to be around in a million more years, so we'll not see more made in our lifetime. Fossil fuels were formed during the time of the dinosaurs. So renewable energy, on the other hand, is from resources that are naturally replenished, like solar and wind. Solar panels, you have seen those, some around town and in the county by some of the county schools. South Green has some, Doak has some out there in the fields. Those are big solar panels. Wind generators, those big wind turbines, are like huge in the Midwest. They are fields and fields and fields of just wind turbines because it's so flat there. The winds just come across the lands, and they use that to generate renewable energy. Using renewable energy will reduce the amount of greenhouse gases released. All right, human activities that contribute to an increase in global temperatures. There's all kinds of stuff that increases global temperatures, guys. So Number 1, transportation. Fossil fuels are used to power planes, trains, cars, trucks, and ships. Greenhouse gases are emitted when fossil fuels are burnt. So that's pretty much common sense. You guys know that. Electricity. Fossil fuels are used to create much of our electricity. Unless you're using solar panels or wind turbines, then for your electricity, then you're probably using fossil fuels. Here's one you don't think of very often, but cement. Cement is mixed with gravel, sand, and water to make concrete. Concrete is used in buildings such as schools and hospitals, and to make roads, and to make sidewalks. And the chemical reaction used to create cement also creates a lot of carbon dioxide. You probably never even thought about that. But think about the chemical reactions we talked about when we did lab right before spring break. And when you made your elephant toothpaste, and if you put your hands on the outside of that beaker, you should have felt the increased temperature, and that was warmth coming off of there, endothermic or exothermic, you tell me. And then it was a chemical reaction. So just a long sidewalk there to talk about chemical reactions, but we have talked about those. All right, agriculture. Agriculture is an important industry that supplies us with food. Greenhouse gases are from cows. Now, a lot of people will talk to you about this, or you have heard about it and you think that it's from cows farting, but really most of the methane is from when they burp or from belching. More is released when they belch than when they pass gas. Yes, you're welcome. And from fertilizer, when there's fertilizer being used, nitrous oxide is released, and that is also a pollutant. All right, industry. Factories that burn fossil fuels release greenhouse gases into the atmosphere. And then deforestation is when trees are cut down or burned. You may have heard slash and burn, where they're just clearing land. And not only if they are burning the land from like a slash and burn type of thing, if they're burning it, they're releasing all that extra carbon dioxide back into the air. If they're just cutting it down, whatever they're using to cut it down is also releasing carbon dioxide in the air. And if there are less plants, then that means less plants to absorb the carbon dioxide for photosynthesis, and more carbon dioxide stays in the atmosphere if there are less trees. So another flashback talking about photosynthesis. It takes water, sunlight, and carbon dioxide to produce oxygen and glucose. And so if there's less trees to absorb that carbon dioxide, then that means more of it's going to stay in the atmosphere. And not only that, if there's less trees, that also means less oxygen is being produced. All right, natural processes. So things that happen every day that occur naturally increase global temperatures, such as like breathing. When animals respirate, including us, when we breathe, we release carbon dioxide. You know this. And that happens from when we exhale, and we start the photosynthesis, so the respiration cycle. All right, decomposition. Decaying organic materials release methane, which is a greenhouse gas. Here's one you don't think about very often, but when volcanoes erupt, not only is there destruction from the lava and the ash and the debris that comes out of a volcano, but the erupting volcanoes release greenhouse gases into the atmosphere. And then solar radiation changes. The sun has stormy and quiet cycles, and what that means is that when it is most active, more solar radiation reaches the Earth. So that increases the amount of heat that's being trapped into the Earth because of the greenhouse effect and greenhouse gases. All right, so that was 2 more pages. You should have 4 total. You should have typed them all in, and then you're going to upload it as one document to Canvas with it filled in. If you printed it and you just want to take pictures of it filled in and upload those, that's fine. Otherwise, upload the document. And email us if you have any questions.